Hello class, good morning. So today we will go to a new subtopic, 1.2, that is inverse variation. So it is just the opposite, opposite of direct variation. And of course inverse, you have any idea about what is inverse? In Malay it is songsang, terbalik, songsang. So it's just the opposite of direct variation. So we proceed, Okay class, we want to know what's the meaning of inverse variation. So before that, we refresh what we have learned in the direct, in direct variation. Okay, you know that if y varies directly as x, you can write it as y equal kx, and you also know that y divided by x will be a constant, that is k. It's a constant. It's the same value all the time when you y divided by x. So it is called direct variation. So for example, if you have one equation like this, y equal 2x, 2x, then we see how the variable will change, the value will change. Let's say x is 1, your y will be, you substitute 1 here, your y will be 2. When your x is 2, this one, your y become 4. So you see, from 1 to 2, you times 2, right? So from 2 for your y, from 2 to 4, you also times 2. So in other words, for direct variation, when x increase, y also increase with the same rate. Okay, with the same rate. If this one is double, the other one also double. You cannot this one double, the other one triple. There's not the same rate. Okay, so that is direct variation. For inverse variation, it is said like this: y varies inversely, 1 over inversely as x. Okay, once again, I repeat how to read this. Y varies inversely, varies inversely as x. So you have to write 1 over x. Okay? Then you can change into equation form, y equal k times 1 over x. It is actually y equal k over x. And from here, you can see that when y times y, or y times x, x times y, you'll get k. And k is the constant. So can you see the difference here? X times y, it's a constant. So it is inverse variation. Y over x is a constant. So it is a direct variation. Direct variation. And it is vice versa. This one, x over y is a constant. It's also a direct variation. This one, y times x is a constant. It's a inverse variation. Okay, so if I want to give you one example, okay, one example, let's say this is your x, this is your y. Let's say you have a equation y equal 2 over x, 2 over x, yeah. This is the inverse variation, 2 over x. So when x is 1, yeah, you put 1 here, substitute 1 here, you'll get 2 over 1. 2 over 1 is 2, so your y is 2. When x is 2, what happened to your y? Your y will be 2 over 2. Y will be 1. So this is 1. Okay, now let's see, let's see. What happened to your x? 1 become 2. It's actually double or times 2, right? What happened to your y? From 2 it become 1. It is actually become half, right? It's divided by 2. So what do you say? Can you say here? Can you now spot the difference between direct and inverse variation? X go up, y also go up with the same rate. That is direct variation. But for inverse variation, you see what happened. When x times 2 increase, your y actually decrease. But with the same rate. If this one times 2, this one divided by 2. Cannot this one times 2, this one divide by 3. That is not the same rate. Okay, so can you get it? Can you get now what is inverse variation? Can and it is vice versa. When y go up, x go down with the same rate. It's either one. Yeah. Okay. Next, so we can conclude in inverse variation, when a variable y increase, yeah, variable x will decrease at the same rate and vice versa. Vice versa means sebaliknya. Then if x increase, then your y will decrease. Vice versa. This relation can be written as y varies inversely as x. Yeah, y varies inversely as x. Okay, class, for inverse variation, y varies inversely as x can be written as like this. Yeah, this is a variation relation, and if it is in equation form, it will be like this. You just times with k. So k will be here. K times 1 will be k over x. Yeah? And then if you draw the graph y against x, it is actually a hyperbola. But if you draw y against 1 over x, you'll get a straight line, and it start from the origin. Yeah, start from the origin. Okay, so far so good. So class, once again, the value of xy is a constant, yeah, if it from the inverse variation. Why? Because when y inverse y varies inversely, yeah, varies inversely as x, you can change it to y equal k over x, and your x you times with y, yeah, you will get a constant, yeah, you will get a constant. That's why here k is x times y. This is just a repetition just now. So the term used is like this, y varies inversely. When it is said that varies inversely as, that means 1 over. Y varies inversely as x. Then you write your x here. So I repeat again. Y varies inversely as variable x. The value of x, y is a constant, k. That is a constant, represented as k. Okay. So in general, yeah, for inverse variation, y varies inversely as x power n, can be written as this one, yeah, as this one. This is in a variation relation. And then you can change into equation, you just put k on top, yeah. So your x power can be power 1, power 2, power 3. X power 2 is actually x square, or the square of x. X power 3 is what? X cube, yeah, x cube, or the cube of x. Okay. What if x power 1 over 2? What is this? This is actually the square root of x. Yeah, x power 1 over 3, this one, it is actually the cube root of x. You have to write a small number 3 here, a small 3 here. But for the square root, no need, understood? Yeah. So your n here can be, either this number, any of this number, and of course k is a constant. And once again, if you draw the graph y against 1 over x power n, you get a straight line that starts from the origin. Yeah, the graph will be, okay, for y, this one must be 1 over x, origin, straight line. And actually, if you find the gradient here, that is your k, yeah. Okay. So we look at one example, example 16. It is given that the time needed t to assemble a piece of furniture varies inversely as, yeah, t varies inversely as what? The number of workers, x. The number of workers, x. So the relation between x and t is shown here, yeah? So by calculating the value of x times t and x squared times t, determine whether t varies inversely as x, this one, or x squared. That means, is it varies inversely as x squared or only 1 over x? Which one? So if you want to know this, you know that when t times x is a constant, then it varies inversely. Yeah? But if tx is not a constant, tx is not a constant, then it does not vary inversely. So what do? You copy back this one, x and your t, this one, same thing. And then x you times with t. This one you get 360. You times this one. You all the time when you times, you'll get a same number, that is a constant. That is a constant. And then your x square. How to find your x square? X square, that means 2 will become 4. 3 will become 9. This one 16. Square it 25. This one will become 30, 36. Then what do? You times with your t. 4 you times with 180. 9 you times with 120. What you get is this number. And unfortunately, it's not a constant. Yeah, this one is not a constant. But x times t is a constant. Hence, we can say t varies inversely as x. So you can write it as this one. Yeah? T varies inversely as x. So this is the answer. Okay? Now we look at example 17. Example 17. Two quantities x and y vary based on the table. Yeah, this table on the right. By using a suitable scale, draw the graph of y against 1 over x, and show that y varies inversely as x. Okay, now your graph here, it is x and y, but you are asked to draw a graph, the graph of y against 1 over x. So what do? So you have to change this 1 over this x into 1 over x. Yeah? All this value will change. Use your calculator. 1 over 2, 1 over 4 here. Yeah. So in the here the solution, it's done for you lah. 0.5 is actually, you get this from 1 over 2. 0.25 is 1 over 4. This one is 1 over 5. This is 1 over 10. Yeah? So you draw the graph, yeah, y against 1 over x. What you get? Okay, so you get this one, straight line, yeah, straight line. And then start from the origin. Straight line start from the origin. So hence you can say, yeah, y varies inversely as x. Okay. Okay, number 18. It is given your x is this one, your y is 3. Express y in the term of x. Yeah. So you know from the question, y varies inversely as x. So you have to write it y equal something over x, right? Okay, so once again you read this question, y varies inversely as is 1 over x. Okay, so you change it into equation k over x. Of course, you want to find what is your k first, right? So you substitute your x and your y. Yeah? Your x and your y. Your y is 3. Your x is 0.25. So you get your k equal what? What is your k? 0.75. So you don't stop there. You substitute back into here. So y equals 0.75 divided by x. So this is the answer of express y in a term of x. Yeah? Y in a term of x. Okay. Okay, now we look at B. Yeah? We look at B. Y varies inversely as square root of x. Square root of x. Yeah? Okay. It is given. You use the same your x and y. Can you use the same k from here? Y equal 0.75 divided by x. Can you use that one? Can you use the same k? No, cannot, because this one different question. This one varies inversely with x. This one varies inversely with square root of x. So cannot use the same k. You have to find your k. How to find? Equal sign. This one. So how to find? You use this one. Your x to 0.25 and your y is 3. 3. Your k is that one you want to find. So 0.25. So k, of course, 3 times the square root of 0.25. So k you will get, this time your k is 1.5. Yeah? Then you substitute inside here. Y become 1.5 over square root of x. So you have answered this one. This is the answer. You see, different. This one, the k is 0.75. Your k now is 1.5. Okay. Okay, example 19. F varies inversely as the square of distance between two objects, that is d. Yeah. So how do you write that? F varies inversely as the square of distance between two of d. So this is d square, because the square, it is stated here, the square. So you change it into equation 5, F equal k, better write it properly, k over d square. It is given that the force of gravity between two objects is 15 Newton. The force is 15. Yeah. When the distance between them is 1.2. So distance is 1.2 cm. Okay, so write an expression of f in the term of d. Okay, this is the expression actually, but it's not complete yet because you have to find what is your k. So this figure, this info will help you. So what you do, you just substitute. Your f is 15. Okay, write back. D is 1.2 square. Then you get your k equal, what is your k? 21.6. Okay, then you substitute back inside here. F equal 21.6 over d square. This is the answer. Express f in a term of d. Yeah, f in a term of d. Okay, next. Okay, we go to the last example 20. It is given that P varies inversely as Q. Yeah. So you write it in equation form. It will be like this. And then your P is 2, your Q is 7. Calculate the value of P when Q is 1.6. Okay, before you can calculate your P, you have to find your K. So how to find your K? You use this information. P is 2, K over Q is 7. So your K is 14. Yeah, you just times 14. Then you substitute back in your equation. P equal 14 over Q. So now it will help you to find your P. Your P equal 14 over Q is 1.6. So your P, you will get 8.75. Yeah, 8.75. Okay, class? Okay. With that examples, I hope you can understand what is inverse. Inverse variation is just the opposite of direct variation, and I hope you will, if you don't understand, you can always ask me, and to stay updated you can subscribe now, yeah, my channel, yeah, Teacher Beth's channel. Okay, see you soon for the next lesson. Thank you, bye bye.